Hello, in this video I'm going to go over a reasonably nice straightforward question from 2021 OCR Further Math Stats. And it just basically tests our understanding of how to work out variances, expectations and transformations thereof. Right, so let's just get on with it. First of all, 7-mark question. Clearly, for it to be a probability distribution, A needs to be equal to 0.4 so that they add up to 1. Okay, so that's first thing. Fairly straightforward. They've got to add up to 1, otherwise, one of them's bound to happen. It's a certainty that one of them happens, so that's all pretty straightforward. So then what I'm going to do is work out the expectation of D. And for that, we just times these two numbers together. So it's that times that, that times that, plus that times that, plus that times that. So that it gives us 0 times 0.4 plus 2 times 0.1 plus 4 times 0.3 plus 6 times 0.2, and that all comes to 2.6. Now the variance of D basically is that times that is the square of this, take away, well, I'll write the formula out, it's worth it. It'll be the sigma of D squared times probability D equals to D minus the expectation squared, which we've worked out, the expectation of D squared. Well, so that's equal to 0 squared times 0.4 plus 2 squared times 0.1 plus 4 squared times 0.2, 0.3 should I say, plus 6 squared times 0.2. That's that bit of the formula. But don't forget to take away the mean squared that we've already worked out, 2.6 squared, so that's equal to 5.64. Right, so we're nearly there already, because probably the quickest way to do this now is just to work out the var of 3D plus 4. Now, if you're doing a transformation with var, if you're finding a linear combination, the var of a linear combination of that, the var of ax plus b is equal to a squared var x, and the b gets dropped. So we just need to make sure we drop the d, put it in, so that's equal to 3 squared times var d. So that's 9 times 5.64, and that comes to 50.76. Okay, so that's it. So we've done that even with me waffling on a bit in less than 4 minutes, and it's a 7-mark question. It is early on in the paper, so it is possible to steal some quick marks at the beginning to get us into the paper. So this shouldn't cause us too many problems. What I would say is there is an alternative, which I think it will do because I've got time on the video, and it might be kind of instructive for other things as well. So the alternative is actually to change the let's say let y be equal to 3d plus 4, and just change the actual thing itself. So it's an alternative. I don't think it's certainly not going to be quicker, but I'm going to do it anyway. So if we say y, which is equal to 3d plus 4, that distribution then would be equal to 0 times 3 plus 4, so that's the distribution for y is 4, that would be our 0. 2 plus 3d plus 4 would be equal to 6 plus 4, which is 10. 4 times 3d plus 4 would be 12 plus 4, which is equal to 16. And 6 times 3d plus 4 is going to be equal to 24 plus 4, which is equal to 3 times 6, sorry, which is 18 plus 4, which is equal to 22. Okay, so that's our distribution. Obviously, the probabilities that y equals to y are the same as they are before. So that equals to 0.4, 0.1, 0.3, 0.2. So then we could work out the e of y. We do need to work out the e of y, which I suppose we could take from our answer before, or we could work it out separately. So it's 4 times 0.4 plus 10 times 0.1 plus 16 times 0.3 plus 22 times 0.2, which obviously will come to the same as we had before, which is equal to, no, we don't actually do need to work this out separately, don't we? Because we haven't had that from before. So that will be equal to 11.8, which itself we can see equal to this times by 3 plus 4. And then we can work out var of y, which is equal to 4 squared times 0.4 plus 10 squared times, but you were basically working out the var of all of these new numbers here, times 0.1 plus 16 squared times 0.3 plus 22 squared times 0.2 minus 11.8 squared, which will give us the same answer. You can check 50.76. I'm no way suggesting that is a better way of doing it. Because the numbers are smaller, it is, I think, quicker and easier, particularly with the 0 here. Quicker and easier to use the transformation. But it's a nice demonstration of how this works, because the main thing is to check that the plus 4 is dropped when you're using the the linear transformation formula. Okay, that's it. I hope you found this useful. Bye.